The second method we'll look at for factoring trinomials when we don't have an a value of 1 is what we refer to as the box method. The box method begins with a similar approach to decomposition. Once again, because we can't factor the 6 out or divide all terms by 6, we're looking for a product of a times c, which is negative 12. We're also looking for a sum with the two center terms of negative 1, meaning that we still have two numbers such as negative 4 times 3 to equal negative 12, and negative 4 plus 3 to equal the negative 1. The difference after that being that we draw a rectangle to now set up the rest of our problem. So I'll start by constructing a rectangle, giving myself plenty of room to work, and I'm going to divide my rectangle into 4 areas. So a lot of the times this is referred to as the box method or the window method, because it tends to resemble a window. What I'd like to do then is take the first term, which is 6x squared, and write that in the first box. And then I'm going to break this center term apart just like I did here, only now I'll write it in the box itself. So I'm going to break that apart into 3x. And the 4 was negative, so I need to make sure I include that sign, and again write the minus 2 at the end. Now the goal of using the box or window method is that we will now be removing a GCF from each row and each column. So we'll be looking at these two terms vertically as well as these two, and then we'll be looking horizontally at each pair as well. So looking across the top here, I have 6x squared and 3x. I can see that a common factor of those two would be 3x. Looking at negative 4 and negative 2, since the leading term here is negative, it's a good common practice that we should remove a negative factor. So since 4 and 2 are both divisible by 2 and the negative starts this, I'm going to remove a negative 2. Factoring vertically here, looking for a GCF, both again are divisible by 2. But since this isn't a leading negative coefficient, I'm just going to factor out a positive 2 here, and since x is present in both, I'll factor out x. And looking over here at 3x and negative 2, I see that there really isn't anything I can factor that is common, but I can always divide both by a positive 1. So looking across the top, I again see that I get 2x plus 1 for one bracket for this factor, as I did earlier. And looking vertically, I see that I get 3x minus 2 as the other factor, which I got in the previous example using decomposition.